So today we are looking at CSEC Additional Math 2022 exam. Alright, so let's jump into it. So question 1, consider the quadratic equation qx squared minus 4px plus pq squared equal to 0, where p and q are both positive integers. Express the sum and product of the roots of the equation in terms of p and q. So we know for the quadratic, the sum of the roots, that's negative b over a, and the product of the roots, that's c over a. So the sum, negative, so in this case a would represent the coefficient of the x squared, which is q. B represents the coefficient of the x, which is negative 4p. And the constant in this case would be pq squared. So the sum, negative b over a, so minus, and then b is the x coefficient, which is minus 4p, over a, the coefficient of the x squared, which is q. So this becomes positive 4p over q. And now the product of the roots, let me just separate it. The product of the roots, c over a, that's a constant, and the constant here is pq squared, over a, which is q, and of course pq squared divided by q into q squared, that's just q, so that's pq. Let's continue. Determine the value of q such that the sum of the roots is equal to the product of the roots. So we are told that the sum of the roots is equal to the product of the roots. Right? So recall that the sum was 4p over q, and the product of the roots was pq. So we are asked to determine the value of q. So we can multiply both sides by q. So q times the left, q times the right. So q into q, so we are left with 4p, and pq times q, that's pq squared. Of course, we are solving for q, so we can divide both sides by p to get rid of the p there. So we end up with p into itself, that's 1, so that's 4. Again, p into itself 1, so we're left with q squared equal to 4. And recall we were told that the values of p and q, they are positive. So we'll take the positive square root. So q is equal to 2. Next. If the sum of the roots of the equation is 20, use your answer from A2 to determine the value of p. So we are told that the sum is equal to 20. Recall that a sum, what's a sum? A sum was jumping all over the place. The sum was 4p over q, right? That's what we found the sum to be. The sum of the roots was 4p over q. So the question says the sum is equal to 20. So we equate 4p over q to 20. And remember, we just found the value of q to be 2. We just found the value of q to be 2, so we replace q with 2. So this becomes 4p over 2 is equal to 20. And of course, 2 into 4p, that's 2p. So we end up with 2p equal to 20. Divide both sides by 2. So p equal 10. Let's continue. Hence, express the given quadratic equation in terms of its numerical coefficients. So recall what the equation was. Equation was, let's remind ourselves what the equation was. So the equation was qx squared. This was the equation qx squared minus 4px plus pq squared equal to 20. Equal to 0 rather. So let's get to the question. So the equation was P. So in part 4, we're asked to express the given quadratic equation in terms of its numerical coefficients. So let's recall what the quadratic was. Originally, this is it, qx squared minus 4px plus pq squared. The equation was qx squared minus 4px plus pq squared equal to 0. So what now? P, remember P was 10, so we substitute. The P is 10, and the value for Q was 2, right? So we plug these into the quadratic, so Q, so that's 2x squared, Q is 2. P is 10, so minus 4 times 10, that's minus 40x. 4 times 10 is negative 40, right? Well, negative 4 times 10. Plus, so P is, the value of P is 10. So pq squared, that's 10 times q squared, q is 2. So 10 times 2 squared, 2 squared 4. 10 times 4, 40. So pq squared equates to 40. And if we notice we can divide, all the numbers here are even. So we can divide the entire equation by 2. So divide 2x squared by 2, we have x squared. Divide by 2, 20x. Divide by 2, 20. And 0 divided by 2, that's 0. So that would be our quadratic. Part B, show that the series is geometric. Now remember a geometric series normally its first term is a, then ar squared, and so on. So to prove this is a geometric, notice with the geometric series, if I divide the second term by the first term, I'll get r. And if I divide the third term by so this is the first term, second term, third term. If I divide the third term by the term before it, the preceding term, I still get r. So a over a into a, r into r squared give me r. Alright, so what's special about a quadratic is that the second term over the first term is a constant, which means that the third term over the term that precedes it, which is the second term, should be the same value. They should be the same thing. Alright, let's see. And that same value should, what is what we call r, or common ratio. So notice the second term here is negative 5. Divide that by 25. And the third term there is 1. Divide by the second term, the term that precedes it. That's negative 5. And notice we end up with negative 1/5 in both cases. So this is equal to this, negative 1/5. So therefore, which is equal to, is what we call the common ratio. So therefore, the series is geometric. Since a term divided by its preceding term gives us a constant, that constant is what we call r. In this case, it's negative 1/5. Let's move on. Calculate the sum to infinity. So the sum to infinity is a over 1 minus r, where a is the first term and R is a common ratio. So A, the first term, that's 25 over 1 minus R, and R is the common ratio, negative 1/5. So this becomes 25 over 1 1/5, right? 1 1/5, which is equal to 25 divided by, so 1 1/5, that's what, 6 over 5? So that's 25 times 5 over 6. Let's flip the 5, 6. Alright? Which is what? 5 times 25, so that's 125 over 6. So the sum to infinity, that's not so clear. So the sum to infinity is, put it here, 125 over 6. And we're asked to write the answer to 2 decimal places. Just notice we want the answer to 2 decimal places. So that would be what, 20.83. So this is equal to 20.83. Part C. A recent university graduate was offered a starting salary of $720,000 for the first year, with increases of $5,000 at the start of every year thereafter. So $720,000 would be the salary for the first year. In the second year, the salary, incremental increases of $5,000, so with now $725,000. This look like an AP. And then 730. So first, this is for the first year. This is for the second year, the third year, and so on. So third year will be 730,000, and then goes on and on until the nth year. All right, the nth year. So with increases of 5,000 at the start of every year, determine the value of the years to the nearest whole number that it would take for her annual salary to be 20% greater than her first salary. So the final salary we want is up to when it is 20% greater than the first year. Now the first year was 720, and 20% of 720. So it's 20% of 720. That's 0.2 times 720. 0.2 times 720. Go to my calculator. That's $144,000. Alright, so this would be 20% of 720. And if I add this to 720, I end up with $864,000. So we want to find out how many years did it take for the salary to increase from $720,000 to 20% greater than her salary in the first year. So 20% of 720, that's 144. Add it to 720, we get 864,000. So we want to know how many years did it take for her salary to increase from 720,000 to 864,000, given that it's increasing by $5,000 each year. So of course it's an AP. No, the formula for AP is A plus n minus 1 D is equal to the nth term. In this case, we're talking about the nth year, and the salary for the nth year, that would be 864,000. A is the first term, 720,000. plus n minus 1, and the common difference, that's 5,000. So let's expand the bracket and solve for n, which should give us our answer. So 720,000, distribute the 5,000, so we have 5,000 times n, 5,000 times minus 1, equal to 864,000. So if we just keep the 5,000 n over here, group everything on the other side, so we end up with plus 5,000 minus 720,000. That will give me 5,000 n equal to, so the right hand side all equates to 149,000. And if we divide both sides by 5,000, we get n equal 29.8 to the nearest whole number with 30. Alright, so the number of years it would take, so it would take 30 years. For her salary to increase to 864,000. Given that it started at 720 and it has been increasing by $5,000 each year. Moving on. Question 2. The polynomial fx 2x cubed minus 3x squared minus cx plus, so we're going to let f of x be equal to 2x cubed minus 3x squared minus cx plus d. And we are told that it's divided by x plus 1 and x minus 2. We get the remainder of 64. Alright, so when divided by x minus 1, we are told the remainder is 64. And when divided by x minus 2, we are told that the remainder is also 64. Which means that f of negative 1 should give us a remainder, should give us a value of 64. And f of positive 2 should also give us a remainder of 64. So f of negative 1, we subtract into this, so we go 2 times minus 1 cube minus 3 times minus 1 square. So we're replacing all x values with minus 1. So it's minus c times minus 1 plus d should be equal to 64. Let's simplify this now. So negative 1 cubed, that's negative 1, times 2, so that's negative 2. Negative 1 squared, that's positive 1, times negative 3, that's negative 3. Negative c times negative 1, that's positive c, plus d equal to 64. If I group, let me put the c plus d, keep these here, group everything. So I end up with 64 plus 2 plus 3. So that c plus d is equal to 69. Alright, so that's one equation. Obviously, we're going to get a pair simultaneous. Let's do f of 2 now, f of positive 2. So f of positive 2, I'm out of space. Let me do f of positive 2 here. Alright, so f of positive 2. So, alright, then f of positive 2, let me just erase. Yeah. So f of positive 2, just making some space here. F of positive 2 will be 2 times 2 cube, so that's 2 times 2 cube minus 3 times 2 square minus 2c, replacing all the x values with 2, plus d equal to 64. Alright, so this should break down to now. So 2 times 2 cube. So 2 cube is 8. 8 times 2, that's 16. 2 square is 4. Times minus 3, that's minus 12. Minus 2c plus d equals 64. So I'll end up with now, let me put in minus 2c plus d over here. Group everything over here. So I'll have 64 plus 12 minus 16. So this will end up become minus 2c plus d is equal to 64 plus 12 minus 16. That should give me 60. So this is the other equation in the pair. And we can solve these by either using substitution or elimination. Let me use elimination method. So we have c plus d equals 69. And we have minus 2c plus d equals 60. Alright, so of course we can subtract. So if I subtract c minus 2c, that's 3c, right? And d minus d 0. 69 minus 60, that's 9. So we end up with 3c equal to 9. Divide both sides by 3, so c is equal to 3. Alright? And then to get the value for d, we can just plug it into, plug it into this equation. This equation, if I plug c here, I will end up with 3 plus d equals 69. And if I subtract 3 from both sides, d is equal to 66. So the solution, c is 3 and d is equal to 66. Next, show that the expression root 25 over root 45 is the same as root 5 over 3. Alright? So root 25 over root 45. So we can rewrite. So root 25, I'm going to write root 25 as root 5 times root 5 times 5. And root 45, I'm going to write as root 9 root. Alright, so I break up 25 into 5 times 5. I break up 45 into 9 times 5. Alright, so remember with surds, root AB is the same thing as root A times root B. So in the same way, I can write this as root 5 times root 5 over root 9 times root 5, and root 5 into itself, that's 1. So we're left with root 5 over 9, and which is root 5, and then root 9 is positive 3. Alright, so this proof was quite easily done. Let's move on to question 2 part C. Given that g of x is equal to that, express g of x in the completed square form there. So g of x, so I'm going to rewrite g of x by factoring out the 6. So if I factor out the 6, I'll have 6 and then x squared plus 6 into 12, that's 2, and 6 into 18, that's 3, right? So I factor out the 6, and then let me complete the square now for what we have in the bracket. So in the bracket, let's complete the square here. So we have x plus half of the b value there, that's 1, minus the square of the 1 here, and then we have a minus 3 outside there, right? So now we can redistribute the 6. So this is 6 x plus 1 square. 6 times minus 1, that's minus 6. 6 times minus 3, that's minus 18. So we end up with 6 x plus 1 square, and minus 6 minus 18, that's minus 24. Alright, using the expression derived in part C, in C1, determine the roots of g of x. So to get the roots of g of x, we're going to equate g of x to 0. And remember, we just wrote g of x as 6 x plus 1 square minus 24 equal to 0. So we can add 24 to both sides. Alright, so we end up with 6x plus 1 all square equal to 24. We can divide both sides by 6. So we are left with x plus 1 all square, or 6 into itself, right? And 24 divided by 6, that's 4. We can take the square root of both sides, which means that x plus 1 is plus or minus the square root of 4. So x plus 1 is plus or minus the square root of 4 is 2, which means x, subtract 1 from both sides, so we end up with x equal to plus or minus 2 minus 1. So x equal to positive 2 minus 1, or x equal to minus 2 minus 1. Alright, so x equal to 1, or x equal to minus 2 minus 1 is minus 3. And the final part of this question, we're asked to draw the graph of g of x. Let's do that. Now, to do this graph, of course, I use freehand there, so remember, you're doing the graphs, you need the ruler and the pen. But anyway, so if you notice the scale I use for the y-axis, I count by 6 because the numbers on the y values for this graph are pretty large, and for the x I count by, I use a 1 to 1, alright, and for the y I use a 1 to 6. Now, the graph, the roots were 1 and negative 3, which means the graph cuts the x-axis at 1 and negative 3. Alright? Cut the x-axis at positive 1 and negative 3. Now if we look back at the graph, here was the original function. The constant was negative 18. So the y-intercept, in other words, the graph cuts the y-axis at negative 18. Which would be here. And then, let's look at when we completed the square. When we completed the square, this was what we got. So you know, the turning point here would have been with whatever bracket, whatever value that makes the bracket 0, which have been negative 1. And then the k value, negative 24. So the turning point would have been minus 1 and positive 24. Minus 1 and negative 24, sorry. Right, so minus 1 and negative 24. So these are the points the graph runs through. So it would look something like that. So that would be the graph of our quadratic. Alright, next. Question 3 is a coordinate geometry problem. The equation of a circle is given as x squared plus y squared plus 4x minus 8y plus 10. Determine the coordinates of its center and the length of the radius. So let's rewrite by grouping. So x squared plus 4x plus y squared minus 8y. And I'm going to put the subtract the negative 10. Subtract 10 from both sides right away. So I minus 10. I'll end up with over here. So if I complete the square, x, positive sign, so we take positive, half of the b value, that's 2, minus the square of this value here, that's 4. Alright, notice if you expand this bracket, you get back x squared plus 4x, x squared plus 2x plus 4, but we don't want any 4, so we subtract the 4, right? Here, y minus half of the b value there, that's 4, minus the square of this value inside here, so minus 16 equal minus 10. So we can group all the constants on one side. So we end up with x plus 2 all square plus y minus 4 all square equal to minus 10 plus 16 plus 4. So this becomes x plus 2 all square plus y minus 4 all square. And so 16 and 4, that's 20, 20 take away 10, that's 10. So the center of the circle is minus 2, whatever values makes the bracket 0. So it's minus 2, positive 4. Remember, the right hand side is equal to r squared. So r squared is equal to 10. Therefore, r is equal to root 10. Next, we're asked to determine the tangent, equation of the tangent of the circle at the point minus 5, 5. Let's do a little sketch here, because they always say a picture is worth 1,000 words. Sometimes a picture is worth more. So a little sketch of the circle here, and the tangent line there will be at the right angles perpendicular to the radius. All right. The point here on the circle, there says we call this point P, and we're told that P is minus 5, 5. And the center of the circle here, we found it to be minus 2, 4. All right. So to get the gradient of the tangent, so here's the tangent. Remember, the tangent touches the circle only once. So to get the gradient of the tangent, we can first find the gradient of the radius r. This is center. From the center, let me call the center O. So we can find the gradient of the radius r, OP, whatever you want to call it. Alright, so the gradient of the radius ROP, so put slash OP, the line that runs from the center, we call O, to the point here on the circumference, is y2 minus y1, y2 minus y1, sorry, over x2 minus x1. So let me call this x1 y1 and this point x2 y2. So in this case it will be 5 minus 4 over minus 5 minus 2. So this will become 1 over 5, take away 4, 1, and it becomes minus 5 plus 2, that's negative a third. Alright? So therefore, the gradient of tangent would be the negative reciprocal. Alright? Remember the gradient, since the tangent and the radius, they are at right angles to each other. They are perpendicular. So the product should give us negative 1. Alright? So 3 times negative 1/3 is negative 1. So the tangent, so for this tangent, the m value, the gradient is equal to 3. Alright? The negative reciprocal of the radius. So we can get the equation for the tangent now. So equation, remember equation of tangent, and the tangent is a straight line. Alright, tangent is a straight line, and it takes the form y equal mx plus c. So we can substitute the line that the tangent passes through, which is negative 5, 5. And we can substitute m negative 5, 5. That's a point P. And m equal to 3. Right? So we end up with what now? Y. So negative, so this is x, this is y. So replace a y with 5. M is positive 3. X is negative 5 plus c. So 5 is equal to minus 15 plus c. And if we add 15 to both sides, c is 5 plus 15. So c is 20. Good? So the equation of the tangent, therefore, equation of tangent is y equal to m, and remember m for the tangent is 3, so 3x plus the constant 20. So that's our solution there. Equation of tangent. Let's move on. So now we're at question 3 part B. So the vectors OX and OY are, so 4I plus j, and OY is I minus 4j. Show that OX and OY are perpendicular. So we know that two vectors are perpendicular if the dot product of the two vectors is the dot product, all right, is 0. So let's find that product of OX dot OY. Let's find that product. So OX, that's 4I. So let's use, so it's 4I and 1j, right? And OY is 1I minus 4j. Let's take that product. So 4 times 1 plus 1 times negative 4. That gives us what? 4 minus 4, which is 0. Alright? So OX, so vectors are perpendicular. Since their dot product is equal to 0. Next, or you could just straight try to find the angle, cos theta. Remember, cos theta is equal to the dot product, over the modulus of both vectors, the modulus of OX times the modulus of OY, and then since the dot product is 0, you end up with cos theta is equal to 0. And theta, so that means theta, cos inverse 0 would be 90 degrees. Alright? So if that product is 0, cos theta would be 0, which means theta would be 0. Theta representing the angle between the two vectors. Alright, let's move on. The diagram not drawn to scale shows a chord, and we can see the chord there, AB, which subtends an angle of 0.5 radians at the center of the circle O. So the center there is O. Then the radius is 10 centimeters, and the area of the triangle is half r squared sine theta. Calculate the area of the shaded region. So area of shaded region would be the area of the sector, which is OAB, which would include the triangle and the shaded region there. So area of sector OAB minus area of the triangle OAB. Alright? And what's the formula for area of sector? When the angle is given in radians, the area of a sector is half r squared theta. We know when the angle is given in degrees, it's theta over 360 times pi r squared. But it's in radians, so we're using the formula half r squared theta minus, and the area of the triangle, where total is half r squared sine theta. Alright, so let's make the substitution. So it's half times, the radius is 10, so 10 squared, times theta. Theta is 0.5 minus half times r squared, again, which is 10 squared, sine theta, so sine 0.5. And if you use a calculator, when you're using a calculator, do ensure that your calculator is in radian mode or R mode. And when the dust settles, you should get 1.03 square centimeters. Alright, you can enter as it is on the calculator and you get the final answer. Next, show that cos 2 theta is equal to 2 cos squared theta minus 1. So we can let left hand side. So left hand side, well, left hand side is cos 2 theta. And we can break up cos 2 theta into, break up 2 theta as theta plus theta. Now there's a formula there that we call the additional formula. It's on the formula sheet that says cos A plus B is equal to cos A cos B minus sin A sin B. So to interpret this, but in this case, A and B, both of them is theta. Alright, both of them is theta. So it's cos theta minus sin theta. Because both A and B would be theta, right? Sin theta. So that's cos square theta. Cos times cos is cos square. And sin times sin is sin square. Now you will recall that another identity that says, it's a Pythagorean identity that says cos square theta plus sin square theta is equal to 1. Let me just separate these. So we can replace cos square theta. So from this identity here, sin square would be 1 minus cos square. If we transpose here, for sin square, this identity, sin square would be 1 minus cos square theta. Alright, so we clear the bracket there. We end up with cos square theta minus 1 and distribute the negative. We end up with positive, well, cos square theta minus 1. We end up with positive cos square theta. So cos square and cos square, that's 2 cos square theta minus 1, which is what the right hand side is in the proof. So the left hand side is equal to the right hand side. So this proof was quite easily done. Next, we're asked to solve the equation cos 2 theta plus cos theta plus 1 equals 0 for the angles 0 to 2 pi. 2 pi is the radian equivalent to 360 degrees. Now we just found that cos 2 theta is identical to 2 cos square theta minus 1 plus cos theta plus 1. So all we did in the first step here is rewrite cos 2 theta as 2 cos square minus 1. Now minus 1 cancel positive 1 there, give us 0, so we end up with just 2 cos square theta plus cos theta is equal to 0. And now we can factor cos theta. So we factor out cos theta. We're left with 2 cos theta plus 1 equal to 0. So we can equate both factors to 0. So we can equate cos theta to 0. Or we can also equate 2 cos theta, the other factor, 2 cos theta plus 1 to 0. So let's solve this now. So theta, now if you are using degrees, the cos of which angle gives you 90 now? So remember the quadrant in which, the quadrant in which cos is positive, alright? So all science teachers are crazy. Alright, so cos is positive in the first quadrant, which for all, and also the fourth quadrant. But it's 0, so 0 cos theta, cos of which angle gives you 0? It's 90 degrees if you're using degrees, 270 degrees if you're using degrees. And if you're using the radians, 90 degrees is equivalent to how many radians? So you multiply by pi over 180, So that's pi over 2 radians. And for 270, you multiply by pi over 180. That's 3 pi over 2 radians. If you want to give the answer in radians. Over here, we solve, subtract 1 from both sides and divide both sides by 2. You transpose a cos theta, you get negative a half. Alright, so if we are using, remember negative a half. So cos we're using the angles for when cos is negative. So cos is negative in the second quadrant and the third quadrant. Alright, so the primary angle here would be cos 60 is half, right? So the primary angle here is 60. So to get the angles there, you subtract 60 from 180. So it's 120 degrees. And you add 6 to get the third quadrant, you add 60 to 180. You get 240 degrees. And if we should convert these angles to radians, you multiply each angle by pi over 180. So multiply 120 by pi over 180, you end up with 2 pi over 3. And if you multiply 240 by pi over 180, I think this is reduced to 4 pi over 3. So depends. So if the angle is in radians, then this would work. Alright? And if you want the angle in degrees, then it's 90, 270, 120, 240. And in the radians, we put the angle in the radians before. Either forms of the solution could work. Let's move on. So move on to question 4 now.